Hello, friends. Good morning, all of you. Today we have to see process management in operating systems. My name is Dange Pratibha Nanasaheb. Now we will start firstly what is mean of process. See, process is nothing but it is defined as an entity which represents the basic unit of work to be implemented in the system. Another definition of process is it is a program in execution. In the life cycle of process, there are lots of the states are there. In the state diagram of the process, you can see different states. That is, six states are there. First one is new, second one ready, third one is running, fourth one is terminated, and fifth one is waiting state. Okay. See, next one, we see new means the process is being created. Ready state, the process is waiting to be assigned to a processor. Running state is instructions are being executed. Waiting state is the process waiting for some event to occur. And last one is terminated. Termination means the process has finished execution. Next point of the in this process management is PCB. PCB is nothing but it's a process control block. In the diagram of process control block is in front of you. It contains process ID, that is each and every process by default given an integer number, that is process ID. Second is state, third pointer, priority, program counter, CPU registers, IO information, accounting information. Such types of different information related to each and every process is contained in the PCB. See, the each and every element in the PCB is explained here. First one is the process state. It can be running or waiting. In the above section, we have seen different types of states are there. These are the six types of state. In that, any one of the state will be here of that process. Then process ID, that is parent process ID. Then process count, program counter, which holds the address of next instruction. Then CPU scheduling information, in which priority information and pointers to scheduling queues, memory management information, in which include page tables or segment tables. And next one is accounting information. It contains the user and kernel CPU time consumed, account numbers, limit, etc. And the last which point covered in the PCB is IO status information. It will include devices allocated, open file tables, etc. Next point of this chapter is process scheduling. The process scheduling is an activity of the process manager that handles the removal of the process, running process from the CPU and the section selection of another process on the basis of a particular strategy. Process scheduling is an essential part of multi-programming operating systems. Such operating systems allow more than one process to be loaded in the executable memory at a time, and the loaded process shares the CPU using time multiplexing. Process scheduling queues. In process scheduling queues, there are three types of queue will be there: job queue, ready queue, and device queue. See the diagram which will shows you job queue means in which job queue is a job queue in which the current execution ready to execute jobs will be in the job queue. Ready queue is there which are feeding to the CPU, and in the CPU actual processing of the jobs will be done, and those processes want some requirement of input outputs that will be in the waiting queue. See the next types. Next point in this chapter is the schedulers. See, scheduler means what? Schedulers are a type of schedulers are a software which are generates the schedules of the jobs or processes, means which process will execute after the another process. See, there are three types of schedulers are there: long term scheduler, medium term or middle term scheduler, and short term scheduler. The name suggests that long term scheduler means it require most longer time to execute the processes. Second one is the medium term. It requires not more or not less medium time to execute the scheduler, and short term means it requires less time to execute. Means in the short term there will be no any waiting queue will be there, because those job will be comes in CPU that gets executed, therefore it requires shorter time to execute. And medium term scheduler is if there will be any IO request then goes into the waiting queue, and therefore it require more time than the short time scheduler. And third one is the long term scheduler, which possess IO request or any resources request, therefore it takes more time than the medium term as well as short term schedulers. See, difference is here of the medium term and long term scheduler. See, long term scheduler, it is a job scheduler, short term scheduler is a CPU scheduler, and third medium term scheduler is a process swapping scheduler. Speed is lesser than short term schedule. Long term speed is less than short term, and short term scheduler is faster among the long term as well as medium term scheduler. And medium term scheduler speed is both in between both short term as well as long term scheduler. These are the different some differences in between three schedulers. Then next point in this chapter is a context switch. See, context switch is a mechanism to store and restore the state or context of the CPU in process control block, so that a CPU execution can be resumed from the same point at the later time. See, the diagram of the context switch is here. In this diagram, CPU is executing. Firstly, process P1 is execute. Then at that same time, if new process which have the more priority than the P1, then its those state of that P1 will be saved and next priority is given to the second process. Again, if the second process is in executing state and third process is come, then again priority is given to the third process. If the third process task get complete, here only two processes are taken, P1 and P2. Means P1 is in running state, at that same time P2 is come and P1's state is saved and P2 is taken in the CPU for the execution. If the P2 successfully completed its execution, after that P1 is gets into the CPU, it completes its execution or start to running. See, in the context switches are computationally intensive since registers and memory state must be saved and restored. To avoid the amount of context switching time, some hardware systems employ two or more sets of processor registers. When the process is switched, the following information is stored for later use, in which first one is program counter, second one is scheduling information, third base and limit register value, fourth currently used register, fifth changed state, sixth IO state information, and sixth one is the accounting information. Then last point of this chapter is the operation on processes. See, there are two main operations can be done on the process, that is the process creation with program, process creation and process termination. These two main operations we can done on any process. See, process creation means process, how to create process. See, process can be created by using fork system call. Fork system call will be apply on the parent process and will it generates the child processes. Then second one is the process termination. Process termination is an operation in which a process is terminated after the execution of its last instruction. Then next point, that is next point is a inter-process communication. See, inter-process communication can be of two types, that is independent process and cooperating processes. See, an independent process means what? Independent process is not affected by the execution of other processes, while a cooperating process can be affected by other executing processes. Means independent process, it does not depend on any other, and cooperating process are depend on the execution of each other. See, process can be communicate with each other by using two ways. First one is shared memory and second one is the message passing. See, in the shared memory, The memory can be shared in between different processes. Therefore, the name is a shared memory. See, communication between processes using shared memory requires processes to share some variable, and it completely depends on how program will implement it. One way of communication using shared memory can be imagined like this. Suppose process P1 and process P2 are executing simultaneously, and they are shared some resources or use some information from the other processes. Process P1 generate information about certain computations or resources being used and keeps it as a record shared memory. When process P2 need to use as the shared information, it check in the record shared in shared memory and take one of the information generated by process P2 and acts accordingly. See, in the figure you can see shared memory. In the shared memory's first figure, you see process A and process B both can use the same region of the memory, means that memory can be shared in between these two processes. Okay, means producer consumer problem is given in the above figure for the better understanding of the shared memory. And the next figure is given in front of the message passing, in front of the shared memory you have given message passing figure. In that you can see process A pass message to kernel and kernel pass that message to the process B. See what happened in the message passing. We can see message passing. In this method processes communicate with each other without using any kind of shared memory. If two processes P1 and P2 want to communicate with each other, they process as follows. Means establish a communication link. Firstly, these two processes establishing communication link. Second one, start exchanging messages using basic primitives. Means in this we need at least two primitives, send and receive. These two primitives are important. In the figure you can see sending processes, message passing module, and process id message. What message is passed by the process that is given to other process, means again that message is passed to the message passing module and again received to the other process, means receiving process. These send and receive, these two primitives are very important. See, the message size can be of fixed size or variable size. If it is of fixed size, it is easy for OS designer but complicated for programmer. And if it of variable size, then it is easy for programmer but complicated for the designer. A standard message can have two parts. Any message or standard message has two parts, header and body. Header means what? The header part is used for storing message type, destination ID, source ID, message length, and control information. The control information contains information like what to do if runs out of buffer space, sequence, number, priority. Generally message is sent using FIFO style. Hope all of you are understanding. Thank you very much, thank you very much all of you, and best luck, good luck for your study. Thank you.